Bismillahirrahmanirrahim. In this lecture, I am solving problem 3.65 from the book Thermodynamics and Engineering Approach by CENGEL, 5th edition. So the statement is a rigid tank contains water. So initially the tank is rigid. So rigid tank means that there is no change in volume. Initially the statement is a rigid tank. So rigid tank means that volume is constant, and this is constant volume process. Contain water at 250 degrees centigrade. T1 is equal to 250 in unknown pressure. When the tank is cooled to 150, after cooling, final temperature is 150 degrees centigrade. The vapor start condensing. It means that at 150 degrees centigrade the condensation starts. So it means that the 250 degrees centigrade is superheated temperature because condensation is this point. Now I am drawing the TS diagram, temperature in degree centigrade, TV diagram. Volume is cubic meter per kg. This is saturation curve. Finally this start condensation. So this is point 2. Condensation mean this is the start point of the condensation and cooling, and then slowly it condenses, and at this point this is completely condensed into liquid form. So start point of the condensation is a saturated vapor line. It means that, and at this point temperature is 150 degrees centigrade. At this point temperature is 150 degrees centigrade, point 2, and initial at point 1 temperature is 250, and this is straight vertical line. So if I draw straight vertical line, so this will be point 1 because at point 1 temperature is 250. We cannot draw this point below because here temperature is decreases, and we know that initial temperature is 250. So initial point is superheated, and point 2 is a start of condensation. This point, this is start of condensation, and this is end of condensation. So and the statement, this is that the statement is that finally at the finally this process, the end of the process is the start of condensation. It means that this is this point. So this is constant volume process. Volume is constant. V1 is equal to V2. V1 is equal to V2. So as we know that point 2 means finally. Point 2 is the start of condensation at temperature T2 is equal to 150 degrees centigrade, and T1 is given to us as 250 degrees centigrade. It means that T1 is equal to 250 degrees centigrade is superheated temperature, and point 1 is in superheated range, and point 1 is in superheated region. So this is the TV diagram. Point 1 is in superheated region, and point 2 is start of condensation. Now volume is constant, so I can easily find V2 because at this point V2 is equal to Vg. V2 is equal to Vg, and at 150 degrees centigrade. So from saturated steam table at temperature T2 is equal to 150 degrees centigrade, volume V2 is equal to Vg, which is equal to check this value at saturated steam table. So this is saturated steam table. Temperature is 150. This is temperature, and this value is 150. Temperature is 150 degrees centigrade, and at this point, volume is, this is VF, and this is VG. VG is 0.39278. 0.39278 meter cube per kg. As volume is constant, so V2 is equal to V1 is equal to 0.39278 meter cube per kg. So it means that we have to find P2 required, right here required is T1 P1, sorry, P1. This is given in the statement to find P1. The estimate the initial pressure at the tank, mean initial, and initial the steam is superheated. Now two values are known to us: temperature 250 degrees centigrade and specific volume V1 is 0.39278. Now from superheat, we use superheated steam table. From superheated steam table at temperature T1 is equal to 250 degrees centigrade and V1. Two quantity are needed to find value at superheated steam table. Find pressure P1 at these two values. So I am checking superheat. This is superheated steam table. If I check the whole steam table superheated, so here temperature is 250. Temperature is 250 degrees centigrade. At this 250 degrees centigrade, the specific volume is 0.39383, but the specific volume is close to this value. With us is close to this value, 0.39383, and the value which is with us is 0.39278. But we have to find at this volume at 250 degrees centigrade, and this volume 250 degrees centigrade is available, but exact this value is not available. So you will do interpolation. So at 250 degrees centigrade and 0.39383, pressure is 600 kilopascal. Similarly, at here at 250 degrees centigrade and volume 0.29314. This value is per volume 0.29314. Pressure is 800 kilopascal. So from the table, at 250 degrees centigrade, specific volume in meter cube per kg and pressure kilopascal. So exact 3.329.39278 is not available in superheated steam table. The value available is at 600 kilopascal. The value is 0.39383. 0.39383. At this point, pressure is 600 kilopascal. And second value which is available is at 250 degrees centigrade, 0.29314. 0.29314. And at this point, pressure is 800 kilopascal. But we have to find the pressure at 0.39278. So do interpolation. Third value minus first value divided by third value minus second value. 0.29314 minus 0.39383 divided by third value minus second value. 0.29314 minus 0.39278 is equal to third minus first divided by third minus second. 800 minus 600 divided by 800 minus P1. So solve this for P1. So P1 is equal to 0. 602 kilopascal. Convert this into megapascal. So to convert kilopascal into megapascal, divide by 1000 megapascal. So P1 is equal to 0.602 megapascal, and this is the final answer. This is the answer in kilopascal and this is the answer in megapascal. And so for more problems, please like and subscribe my YouTube channel and share with your friend. Thank you.